Hello, welcome to this lesson on our study of solutions to the wave equations. Okay, alright, so if you have not subscribed to this channel, kindly subscribe for more videos and so like my video and comment. Okay, well, we have this problem here to solve. Okay, if you remember, in our first discussion or in our first lesson, we developed a formula that if you have a wave equation like this, okay, and has a condition given as ux, 0 equals some f of x, and then ut, x, 0 equals some g of x, then simply our solution to the wave equation from D'Alembert's formula is given as u of s, t is equal to 1 over 2 then times the bracket f of x minus or x plus ct and plus f of x minus ct plus 1 over 2c integral of g of tau d tau from x minus ct to x plus ct. We proved this formula in our first discussion. Okay, so this is the solution. Now comparing these to the question above here, okay, if you want to compare them, let me use a different color. Compare these to that, it means that our f of x in this question given is equal to 0. So it implies that f of x plus ct is equal to 0 and f of x minus ct is also the same as 0. Okay, they are the same because you don't have any expression in the f of x for us to put x plus c, so it means that it is a constant function, so it means f of x minus ct is also equal to 0. Now g of tau is equal to sine of tau because we have g of x, okay, equal to, let me write a g of x first. I hope you can see it. Comparing to what we know, it means g of x is also equal to sine x. Okay, because we said that from the D'Alembert's formula, the equation should be the same as the question we have here. Okay, but the conditions are u of s, 0 is equal to f of x. It means that for this particular question, this is f of x, and ut of s, 0 is equal to g of x. So it means for this particular question, g of x is equal to sine x. Okay, which then implies that f of g of tau, okay, g of tau is equal to sine of tau. Very simple like that. Okay, so immediately we see that we have all these. That means that our solution u of s, t is equal to half into 0 plus 0 then plus 1 over 2c, okay, 2c integral from x minus ct to x plus ct sine of tau d tau. Okay, because our g of tau d tau is given us, or our g of tau is given as sine of tau. Okay, so u of x, t would then be equal to 1 over 2c the integral from x minus ct to x plus ct then sine of, okay, tau d tau. And this becomes simple for us to solve because we only have to do, sorry, I have some w here, I have to change that. It should be u of that. Okay, u of this. So we only have u of xt being equal to 1 over 2c the integral of sine is what? Minus cosine. Okay, so it's minus cosine of tau then from x minus ct to x plus ct. Okay, so if I put everything in, I'll get my u of xt being equal to negative 1 over 2c. I'm putting my limit in, and I'll get the bracket cos of s plus ct in bracket minus sine of x minus minus cos of that, the same thing, x cos of x minus ct. Okay, alright, so this is the final answer. Now looking at the bracket here, what we have in the bracket here, okay, it's kind of depicting some trigonometric properties, but then before that, let's look at this. If I have cos of a plus b, okay, it's the same as cos a cos b minus sine a sine b. Okay, this simply means that the cos of x plus ct here that we have, a being our x and b being our ct, we'll get something like this. Let me use a different color. You get cos of x cos of ct, okay, know that is cos of ct, minus sine of x sine of ct, and also with cos of a minus b, okay, we have the solution to be cos a cos b plus sine a sine b. Okay, this implies that we have a cos of x minus ct, okay, x minus ct to be equal to cos of x cos of ct plus sine of x sine of ct. Now with these two equations, I want to find cos. Okay, if you can see what we are getting here, you could see that my cos of x plus ct, that was in our answer, okay, then minus cos of x minus ct. This is what we had. Let's go and check. This is what we have here. We have cos of x plus ct minus cos of x minus ct. It should be equal to, it means you are having to subtract this equation and this equation. Okay, so if you subtract them, you have already subtracted this side, the left side of the equations already, which gives us this. Okay, so let's try to subtract the right side as well. Okay, alright, so if you subtract the right side, you can see that cos of x cos ct will cancel themselves, because this minus this will be 0, and we'll be left with minus this minus that, and we'll get minus 2 sine of x sine ct. Okay, so it means that whatever that we have in the bracket as cos of x plus ct minus cos of x minus ct is now equal to minus 2 sine x sine ct. So we come to our function here, our solution, and put that in. Okay, so sorry, I have my u of xt being equal to this. Okay, let me push it to the top. Okay, we know that u of xt or s comma t is equal to negative 1 over 2c in bracket cos x plus ct minus cos x minus ct. Okay, this is what we had, and we know the expression for this. Okay, it is just this one. Okay, so it means our solution will be equal to minus 1 over 2c, then multiplying negative 2 sine of x sine of ct, and now this can take this out, the 2, and then when you multiply through by negative, we get 1 over, we get a positive, so 1 over c sine of ct, or sine of x, anyhow you want to write it, sine ct, which is our u of xt. Okay, so this is very simple. Okay, so this is a solution to the question we had here. Okay, let's go ahead and solve a more complex example and see. Wow, you have a wave equation with a source and we have other terms inside as well. Okay, but mind you, this is a very simple second order PD that we can solve. Okay, if you have watched a video on how to solve second order PD by me, you could see that I mostly say we have to compare it to A U T T. Even in our first discussion I said this, plus B U X T plus C U X X. Since we don't have any other terms in, let me say this plus some functions equals some, or let's say plus other stuff. So the other stuffs I wrote them in our last discussion. Okay, equals some g of, okay, this was g of xt. Okay, now these stuffs I hope you can write them. They're just the first derivatives and also the normal function u. Okay, so you get like d u t plus e u x plus f u. Those are the terms missing here. Okay, but since we have only these, that is why I just prefer this. Comparing this to that, you could see that a is equal to what, 3. Okay, b is equal to 10 and c is equal to 3 as well. Okay, so if I have this, then how do I go about it? Okay, let's see. If you have this, we first check b squared minus 4ac, and we are saying b is what, 10, so 10 squared minus 4, 3, then another 3, and this will give me 64, which is greater than 0. So it means always, I said this in our first discussion as well, I said that the wave equation is a hyperbolic function or hyperbolic in nature. Okay, so what I have to do is just solve this dx dt, which is equal to b plus or minus the square root of b squared minus 4ac over 2a, and this implies I have dx dt equals 10 plus or minus square root of 64 over 2 into 3. Okay, and 2 times 3 is what, 6. All right, I have this. This will simply give me 10 over 6 plus or minus square root of 64 is 8 over 6. Okay, so I have the x dt being equal to 10 over 6 is 5 over 3. Okay, then plus or minus 4 over 3 as well. Okay, so in the first place, if I consider the positive part, okay, it becomes 5 plus 4 over 3, which is 9 over 3, and I'll have dx dt being equal to 5 over 3 in a positive part. Okay, we are considering only the addition sign, so I have 5 over 3 plus 4 over 3, and this will give me 9 over 3, which is 3. Okay, so it means in the first positive part, I have these ones, dx dt being equal to 3, which implies that in solving this characteristic equation, I'll get dx is equal to 3 dt, and so I'll have something like x is equal to 3t plus, let's say, s. Okay, and this means this s, which is the constant, is equal to s minus 3t. Okay, so I have this as my first characteristic equation. Okay, now we continue with the other case, that what if dx dt is also equal to, let's say it is also equal to 5 over 3 minus 4 over 3. Okay, this will imply that we'll have 1 over 3, which means the x dt will be equal to 1 over 3. Okay, and in that case we'll have something like the x being equal to 1 over 3 dt, and so if I solve this, I'll get x is equal to 1 over 3 t plus some constant, let's say tau. So it means our second characteristic equation is tau is equal to x minus 1 over 3 t. And so this function to also characterize our PD or our wave equation. Okay, so we come up here and write them somewhere. Okay, I want to write them here so that we can come back for them when you want them. Okay, I hope you understood the process. Okay, so what we actually want to do is we actually want to find UTT, UXT, and UXX, so that at the end of everything we'll be able to substitute them in and simplify our equation. Okay, so I have first S equals, okay, I have S here, which is equal to x minus 3t as one of them, and tau here, which is equal to x minus 1 over 3t. Okay, now keep these in mind. Okay, but let's see something before that. Okay, before we go for our UTT and our UXX, you see that our source function here is what? Sine of x plus t, and in the substitution you want to find UTT, like I said earlier, so that I can substitute them back here, but we have to also change the x plus t to tau and s. Okay, so from these two equations, okay, if I subtract them, s minus tau will be giving us what? X minus 3t minus what? X minus 1 over 3t. Okay, and this will give me x minus tau is equal to, how do I call it, x, so you subtract everything, so x minus 3t minus x plus 1 over 3t. Okay, and so it means that x will go x minus 3t, x minus that, so we'll get something like s minus tau is equal to this. When I subtract these ones, okay, I'll get 3 times that, okay, which is negative 3t, then plus 1t, which will give me negative 9, sorry, negative 9t plus 1, which will give me negative 8t over 3. Okay, so in other words, this implies that we have 3 into s minus tau equals negative 8 or negative 8t. Okay, so it means that my t will be equal to dividing through by 8, and I'll get t being equal to negative 8. Okay, you divide through by negative 8, and then this, the tau will become plus. Okay, if I divide through by negative 8 or negative 8, yes, I get 3 over 8. Okay, but it will just, the negative sign will just interchange s and tau. Okay, so I'll get tau minus s rather. Okay, it is very, very simple like that, which is the same as, let's say, 3 tau over 8 minus s over 8. Alright, so 3s over 8 rather. Okay, so it's supposed to be, the 3 is multiplying all of them, so that's my t. Okay, so let's write t somewhere and also find our x. This is very, very long, I know, but if you pay attention and study clearly, you can see that you'll be able to solve every wave equation that will be given to you without using any big formula. Okay, once you understand this process, you know that t is also equal to 3 tau over 8 minus 3s over 8. Now let's come back and find my x. Okay, if that is t, then we can put x t in place of any of these and go. Okay, so it means that the first equation, s, which is equal to x minus 3, then t is what? 3 tau over 8 minus 3s over 8. Okay, if I substitute everything and work through this, I'll get x equals 9 tau over 8 minus s over 8. Okay, you can actually confirm this, right? If I multiply through by this 3 here, I'll get negative 9 tau over 8. Okay, and if I multiply this, I'll get positive 9s over 8. I'll get something like s minus, is it 9s over 8 at the right side, then plus 9 tau over 8 is equal to x. So if you work through it, you can see that this here minus that will give me the minus s over 8, then it becomes 9 tau plus that. Okay, so let's write x also here, and finally write some simple stuffs here. Okay, so I know that my x is also equal to 9 tau over 8 minus s over 8. So we keep these, and then let's find x plus tau, or s plus t, sorry, in this equation, the sign side. Okay, so s plus t is now equal to 3 tau over 8 minus 3s over 8 plus 9 tau over 8 minus s over 8. And this will simply give me, if you go through the computation very well, okay, this will simply give me 3 over 2 tau minus 1 over 2s. Okay, so this will be my x plus t. Okay, so let me clean it and write it here, so that when we are transforming it, we just transform them straight away. Okay, this is equal to 3 over 2 tau minus 1 over 2s. Very simple like that. Okay, so we don't actually need these ones. We just wanted to know how to go about them. Okay, so let's circle this as well. All right, so let's go ahead and find our utt, uxx, and uxt. Okay, so here you know that ut is equal to del u del s dot del s del t, then plus, okay, plus del u del tau dot del tau del t, and this will simply give me, if you pick your tau and x clearly, you get this to be negative 3 us minus 1 over 3 u tau. Okay, my utt is simply the second derivative with respect to t of ut. Okay, this is how you write. So del t is supposed to be del, so del t of minus 3 us minus 1 over 3 u tau. Okay, now I will be shortening things here because it's very long. I've been going through this process with you, so I believe you can do this. Okay, so I'll get something like minus 3 del s of ut. I hope you can go through this and see why I'm writing this. Del s, or del tau here of ut. Simply just interchange this and this and multiply it by that, interchange this and this as well, and do that. That is all. So if you go through this, you know your ut to be this, so you come and put your u2 here and your ut here and do the differentiation. Okay, so if I do the differentiation clearly, I'm supposed to get this. Let me write this straight away for you and explain things to you. Okay, so this is supposed to be this. Alright, so utt will be equal to minus 3 into del s of, now my ut was negative 3 us minus 1 over 3 u tau minus 1 over 3, then negative 3 us minus 1 over 3 u tau. So this will actually yield, I'm writing the answer straight, and I'm urging you to go through the process yourself. You know, this will del s of this side will give you negative 3 uss, then that will give me negative 1 over 3 u tau s, all multiplied by negative 3 here. Okay, I hope you can see what I'm trying to say. So in effect, after simplification, you get UTT to be 9U SS plus 2U tau S and plus 1 over 9 U tau tau. Kindly go through the derivations to get this. Okay, I know you can do that because you've done this in our first discussion, how to do partial derivatives and stuff using the chain rule. Okay, so this is my UTT. Let's go for UX and see. So UX is actually equal to del U del S dot del S del X plus del U del tau dot del tau del X. Now this will give me differentiation of S with respect to X is 1. Okay, so you have US plus U tau, both of them like that, and UXX is actually equal to del X of UX, which is equal to del X of US plus U tau, and this will give me del S, okay, of UX plus del tau of UX. I hope you can see this, and I believe by now you understand this process. Okay, kindly follow and understand it. So UXX will be equal to del S of UX, which is US here, sorry, plus U tau. Then I have del tau of US plus U tau. Okay, now let's move ahead and see what we are getting here. If you go through the process carefully, this one too, I'll just quote it and ask you to go ahead and find it. Okay, USS will be equal to USS plus 2U tau S plus U tau tau. This is what I want you to do. Okay, just go ahead and find a solution to this. You can simplify this on your own. Okay, now let's go ahead and find UX tau. So you know that UX is equal to US here plus U tau UT. Okay, this means that UXT is equal to del T of my UX, and this is equal to del T of US plus U T. Is it U tau rather? Okay, it's U tau rather. Okay, U tau then tau. Okay, and this is the same as del S here, then UT plus del tau of UT, and this will give me UXT being equal to del S of UT, which is negative 3U S, okay, minus 1 over 3 U tau plus del tau of negative 3 US, okay, minus 1 over 3 U tau. Okay, like that. And if you go through the derivations carefully, you see that UXT will also give you negative 3 USS minus 10 over 3 U tau S minus U tau S minus 1 over 3. Is it 1 over 3? Yeah, I guess so. Okay, let me see what I have here. Is it 1 over 3? Yes, it's 1 over 3 rather. Okay, so I have 1 over 3 U tau tau. So we have all that we need to go. Okay, we have this one here. So let's go back to our equation and write it again. Okay, let's write our equation again. So the equation here was, the question we were supposed to solve was giving us this UTT. Is it 3 of that? Okay, it's 3 UTT plus 10 UXT plus 3uxx is equal to sine of x plus t, and we know x plus t from our first derivation is what we just did, and so we simply go ahead and put them in. So we have this to be 3 times that. Okay, utt was given us what? You go ahead and find utt, which is this. Okay, so you put 3 then you know uxx is also this. Go ahead and find our uxt, which is also this. Okay, so we just put everything there like that. So 3, then utt was given us 9uss. I said you can go through this and solve it. Okay, 2u tau s and plus 1 over 9 u tau tau. Okay, and plus 10 times utt, which uxt, which is negative 3 us. Okay, minus 10 over 3 u tau s, and is minus 1 over 3 u tau tau. Okay, then in brackets plus 3 into uxx, which is uss, plus 2u tau s plus u tau tau, and all of this should be equal to sine of x plus t, and x plus t was given us 3 over 2 tau minus 1 over 2s. So simply we have to simplify our expression here. Okay, so expanding we'll get 39, which is 27 uss plus 6 u tau s plus 1 over 3 u tau tau minus 30 uss minus 100 over 3 u tau s minus 10 over 3 u tau tau plus 3 uss plus 2, it's supposed to be 6 u tau s plus 3 u tau tau is equal to sine of 3 over 2 tau plus, or is it minus? It's minus 1 over 2 s. Okay, all of this is equal to that, and let's look at how we can cancel some of the terms out. Okay, you could see that we have 27 uss plus 3 uss becomes 30, so they will cancel this negative 30 uss. Very, very simple. Okay, now if you add this u tau tau here, 1 over 3 u tau tau plus 3 u tau tau, it becomes 10 over 3 u tau tau, and they will all cancel negative that. Okay, so I'll be left with 6 u tau s plus 6 u tau s minus this. So if I add all of them, I'll get negative 64 over 3 u tau s is equal to sine of 3 on 2 tau. Okay, tau here minus 1 over 2s. This has become very simple for us to solve. Okay, so this is a PDE that you want to solve. Okay, and so with this PDE we have non-homogeneous, and with the non-homogeneous I said that if you have something like this, you can break it into two: u homogeneous, u particular. Okay, so your u of s comma tau should be equal to the solution you get homogeneous plus the solution you get in particular. Okay, so in solving the homogeneous will be the solution of this side, setting the left hand side involving the derivatives should be equal to 0. So the solution to this will have to give us that, and this means that my u tau s should be equal to 0 when I divide through by negative 64 over 3. So this is what we have to solve for the homogeneous part. Okay, so let's move ahead and solve it. Now I have u s tau, or u tau s, anyhow you call it, is equal to 0. If you remember in our first questions, or I think in a second question rather, in the solutions to some of the samples of second order PDE, I said that with this equation you can first integrate with respect to s on both sides, and when you integrate 0 you get a constant. This is because we are dealing with indefinite integrals here. Okay, you get a constant, and the constant should be in terms of what? Tau, since u depends on both s and tau. So here if I integrate with respect to s ds here, and so we have to get a constant in terms of tau. I hope you understand this. Now we can integrate this side with respect to tau, this with respect to tau, and this side with respect to tau. Okay, you could see that you get u of s tau, which is the homogeneous part, is equal to, integrate this with respect to tau, you get still another function in terms of tau. So you get capital F of tau plus then a constant, and the constant should be in terms of s. So this is very simple for my homogeneous. Okay, let's move ahead and find our u particular. So the equation here that we have, with this equation, you are saying that you have to write a general form of the function at the right side. Okay, that will be your particular solution. So looking at sine, okay, you have sine of something. Sine always normally goes with cos, they move together. So if the right side is in terms of sine, then it means the particular solution we are suggesting is supposed to be in terms of sine and cos. Okay, for trig functions, this is how you write a particular solution. So we are saying that u particular, we let our u particular be equal to a, then sine of the same thing that is in the bracket, 3 over 2 tau minus 1 over 2 s, plus b cos of the same thing, 3 over 2 tau minus what we have 1 over 2s. Okay, these are our solutions, our particular solutions. So first of all, you have to find u tau. Okay, you're supposed to find u tau s and come and put it back in the equation, since the equation is like this. Okay, you're supposed to find this one, u tau s, and put it back and find our coefficients. Okay, so u tau will be equal to, differentiating the whole of this with respect to tau. First you differentiate the bracket, you get 3 over 2. So I have 3 over 2, then times 3 over 2 here, a is a constant, so times a, then differentiate sign, you get cos of whatever that is in the bracket there. Okay, minus 1 over 2s. Then when you differentiate the bracket, you get what? 3 over 2, the same thing for this cos side, but when you differentiate cos, you get minus sign, so you get minus 3b over 2 sine of 3 over 2 tau minus 1 over 2s. Then you have to find u tau s. So you have to differentiate u tau with respect to s. And do that and differentiate the bracket with respect to s in the first place, as in with this part. With this part, when you differentiate with respect to s, you get negative half. And when you differentiate cos, you get minus sign, so the negative will cancel it. So I'll get negative half times negative something, so it becomes positive half. So I have half times 3 over 2a, which will be 3 over 4. Okay, you have 3 over 4 a, then sine of 3 tau over 2 minus 1 over 2s. Then with this part 2, if I differentiate the bracket, I'll get negative 1 over 2, but if I differentiate sign, I'll get cos. So I'll have minus 3b over 2 times negative, so it becomes plus 3 over 4 as well, or 3b over 4, then cos 3 over 2 tau minus 1 over 2s. Okay, this is what we have for it. So we come back and put it in our equation. Okay, the equation is negative, the equation is this, negative 64. Okay, so it's negative 64 over 3, then u tau s should be equal to sine of, okay, 3 tau over 2 minus 1 over 2s. So I know my u tau s. Okay, so I have, that is what we just calculated, or we just found. So I have negative 64 over 3. U tau s was given us 3a over 4, then sine of 3 tau over 4 over 2, sorry, minus 1 over 2s, then plus 3b over 4 cos of 3 tau over 2 minus 1 over 2s. Okay, all of these should be equal to sine of 3 tau over 2 minus 1 over 2s. Okay, so if I multiply negative 64 over 3 through the whole of this at the left side of the equation, I will get something like, in the first part, okay, 3 will cancel 3 here, and 4 goes into here, negative 16. Okay, that's for the first part. At least, in fact, it will happen for both parts. Okay, so you have 3 over 4 here as well. So you have negative 16a sine of 3 tau over 2 minus 1 over 2s plus, sorry, it's supposed to be negative 16 as well, so you get minus 16b cos of 3 tau over 2 minus 1 over s, sorry, 1 over 2s rather. Okay, and this should be equal to sine of 3 tau over 2 minus 1 over 2s. And now, you see, if I'm supposed to add a cos, then it's plus cos 3 over 2 tau minus 1 over 2s. Okay, this is how it is, plus 0 of that. Now we have to compare coefficients. Okay, you have to compare coefficients, and so with the comparison, you could see that the coefficient of sine at the left side of the equation should be equal to the coefficient of sine at the right side, and the coefficient of sine is 1 at the right side. Okay, so minus 16a should be equal to 1, and a is equal to what? Negative 1 over 16. Okay, now with b, minus 16b should be equal to 0, and b is equal to what? 0. But we propose that u particular, so we are done. We are just finding a and b. Okay, since we've been able to find a and b, we are done. We proposed in the equation that our u particular should be equal to a sine of 3 tau over 2 minus s over 2 plus b cos of 3 tau over 2 minus 1 over 2s. Okay, or s over 2, anyhow you want to write it. And now b is 0 and a is that, so it means our actual u particular is also equal to minus 1 over 16 then sine of 3 tau over 2 minus s over 2, or 1 over 2s, anyhow you want to call it. So this is our u particular. So our final answer in terms of s and tau is u of s tau is equal to u homogeneous, okay, plus u particular. And u homogeneous was given as what? F of s plus f of, sorry, g of tau. Okay, then particular is what? Minus 1 over 16 sine of 3 tau over 2 minus 1 over 2s. Okay, that's what we have here. So this simply means that my u of xt, very easy, u of xt is equal to capital F of, now x is what? F of s is giving us x minus 3t, that's my x, and plus g of tau, which is x minus 1 over 3t minus negative 1 over 16 sine of, now what is 3 tau over 2 minus 1 over 2s? It was actually x plus t that gave us that. Okay, so this is our final solution to the question we were solving here. Very easy, okay, but long process. If you understand this process, you can actually solve all second order PDE like this. Okay, the only thing you need to do is just go through the process, understand the process, and use it often. Thank you, and don't forget to subscribe to my channel if you have not subscribed, and also like my video. All right.